Alright, this is attempt number 2 at doing this video. The first time around my pen died mid-video, so name is Trent, block, date 13th, I think. I don't even know. Alright, the odds against a particular event happening are 9 to 6. That means like the chances that it happens are 6 and the chances that it doesn't happen is 9. Odds in favor, you just flip it, 6 to 9. And then this can be simplified if you divide both sides by 3, 2 to 3. So that's our final answer. Alright, what is the probability that the event will happen? So you take your total chance that it's going to happen, and then you put it over your total everything. So 6 over 6 plus 9 is 6 out of 15. Is not equals, but roughly 40%. A high school football coach is, it does equal 40% actually. A high school football coach is trying to decide which quarterback he should start in the next week's game. He examines the win-loss ratio for the two quarterbacks. Okay, so wins. If you want your win ratio, just go exactly the same as up here. Your wins over total. 13. 61.5%. And then this one you have wins of 7 over total games. 7 out of 11 equals 63.6%. So like based off this purely, you'd say Gabriel. Then you can say stuff like, Jermaine's played more games, so you have a bigger sample space and stuff, but obviously they're just going off the raw thing now. So just percentages, 63.6 is higher than 61.5. Alright, 3 students, Drew, Eli, and Aaron, are in the running for captain of the school football team. Drew has a 40% chance, Eli has 32% chance. So Aaron would be a 28% chance. And this isn't just for this specific question, just overall. Put it up there. But the odds in favor of Drew being voted captain, so 40. And then your total percent is 60. Is 100, so the other side is 60. So 4 to 6, 2 to 3. Odds. The odds against Eli being voted captain, so 70, 68 to 32%. And then that simplifies. If you divide both sides by 4, you get 17 to 8. And then the odds. So, by the way, if it's against, you put the chance they don't get it first. And if it's odds 4, you put the odds that they get it first. That's all I'm doing, just as a side note, because I realized I never actually specified that. So here, the odds against Aaron being voted captain. Aaron's chance is 28%, so the odds against 72 to 28. And that simplifies to 18 to 7. If you divide both sides by 4 again. Bang, done. Probability that Alvin's mother will serve rice with dinner is 0.78. Probability that she will serve carrots with dinner is 0.30. Probability that she will serve neither rice nor carrots is 0.14. Draw a Venn diagram. So, Venn diagrams, I know, look like this. And the box is for neither of them. So 0.14 goes out here. And then we know that this red bit, let's say carrots and rice, right? The red bit will add up to 0.3, and the green bit, whoa, highlighted. The green bit, sorry, will add up to 0.78. But you see, when we draw this Venn diagram, we have this overlapping bit in the middle, right? And so to figure out what that doubles out, we go 1 minus 0.14. So 1's our total, minus the bit that's not included, 0.86. And then what we have in here is 0.78 plus 0.30. Right? Is our total in there. And then minus 0.86 is 0.22. So we know that this bit in the middle here that doubles up must be 0.22, because we've said, okay, how much is left over, right, in our 1? So we've got 0.86 left over. So what this should actually cover is 0.86. What it does cover is 1.08. And so that bit that's doubling up, it's another way of showing it. The bit that's doubling up is that 0.22. If you take out that double up, you get that correct in the middle. So 0.22. And then once you've done that, you just take away that 0.22 from each of the components. So 0.78 minus 0.2256. So, and then 0.08. So the chance that you get carrots and not rice is 0.08. The chance that you get rice and not carrots is 0.56. The chance that you get both is 0.22, and the chance that you get neither is 0.14. Determine the probability that Alvin's mother will serve both rice and carrots. Okay, so that's just 22%. From above diagram. Don't need to show any working out for that. We've just worked it out up here. Jessica's, also I've realized in the answers they use actual notation for this. They said like P, R, and C equals P, R plus P minus P. So this means intersecting, and then this mean, that shouldn't be a U, I'm just drawing that out of habit, means union. Okay, so like the U is easy to remember, union, and then I just remember that the opposite way is intersecting. So it's the total, it's R plus equals P minus P. Oh, actually, this might just be PRUC. Yeah. So all the notation, that's basically all you need to know. Is that the intersecting is the one that goes down and the union is the one that goes up. But you don't actually need that. It's more just common sense to solve the question up here. You just go, how much am I like overflowing by? And then you take away that amount from each of them. Jessica is playing a game of solitaire using a well-shuffled deck of 52 cards. She lays out 7 cards face up to determine the probability that they will all be spades. Okay. There's 2 ways of doing this. You've got the way that, like, I'll explain, and then the shortcut for that. So the way I'll explain, what's the chance that you get 1 spade, let's say? That's 13 out of 52, right? and then the chance that you get 2 spades in a row, you've now taken out a spade. 51. Taking out a spade times 9/48. 1, 2, 3, 4, 5. 8/47. 6 times 7. 1, 2, 3, 4, 5, 6, 7. Bang. Okay, so if you do this, this will equal your probability. And the reason why is you say, like, what's the odds of me picking that first card out and it being a spade? What's the odds of the second card, etc. And the top and the bottom each decrease by 1 because you keep taking out a card and you keep taking out a spade. But the reason they're all multiplied is in probability, and means you multiply or means you add. Right, so in this case we're saying we're picking out a spade and 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 a spade, and so it's multiplying between all of them. But the shortcut for this is we're essentially saying this top bit, like 13, is 13, choose 7. That's the shortcut way of saying it. And then same on the bottom, 52 times 51 times 50. Equals 52, choose 7. So then our final answer would be 13, choose 7, divided by 52, choose 7. And then you chuck that in your calculator. Apparently it gives you 0.0000128 as your final answer. So yeah, if you don't know what to do, I'm not about to go do it because it'll take ages, but if you entered this, it would give you the same thing. This is just the shortcut for doing that. Okay, next one. A child randomly arranges 10 different books on a bookshelf. What's the probability that the Cat in the Hat, Green Eggs and Ham, and Horden Hears a Who will be placed together? Okay, so essentially you've got 10 spots. 1, 2, 3, 4, 5, 6, 7, 9, 10. And you want them all 3 together. So let's just say it's these 3 spots, right? We've got those 3 together and the other books all along. Now, how many times can we move that set of 3? So it could be those 3, or it could be these 3, or it could be these 3, or it could be these 3, it could be these 3. So you just move it along by 1 each time. And it can be these 3. It can be these 3. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 ways that you can do it. In terms of like having the 3 together. And then in terms of actually inside the 3, you can arrange it 6 different ways, because you can, like, it's 3, choose. Oh my word, I'm mixing up my notation in my head. You can put 3 books in the first one, and you've got 2 books to choose to put in the second one, and 1 book that can go there, right? So let's say instead of these 3 titles, you have red, blue, green, right? And you have 3 spots. Any of the 3 can go in the first one. So it's 3 options. I'll put O for options. Then you've put something in the first one. So you have 2 options to put in the second one. Then you've got something at the end. Multiply them together equals 6, right? So 8 times 6. And then this is 3 factorial. So if you have spots and there's no repeats, that amount factorial will be your answer. And so if we apply that same logic to over here. We've got 7 spots with no repeating books because there are 10 different books. And so it's going to be 7 factorial different ways of arranging the rest of the books. And so this is times 7 factorial. And apparently that is 2, 4, 1, 9, 2, 0. Right? And then that isn't our final answer because they're asking what's the probability that they'll be together. So this is the total amount that they'll be together. And then the total amount, if you erase all of this, you just say I've got 10 books. You've got 10 spots, so it's going to be 10 factorial total ways of arranging them. So the amount that they'll be together over the total amount of arrangements. And then you get 6.7% if you chuck that in your calculator. Alright, next one. Liam has 7 red marbles and 5 blue marbles in a bag. He draws 2 marbles, one after the other, without replacing the first marble. Determine the probability that both marbles are red. Okay, so I'm just going to do this. It says draw a tree diagram. I was going to do it anyways, just to show you. But I'll show you the 2 different methods. So tree diagram, if you want to actually draw it, red, blue, red, blue, red, blue. So what are the chances that you get red first? Well, there's 7 red out of 7 plus 5, 12 total, right? So 7 on 12. And then the chance you get blue, 5 on 12. And a tip for drawing these tree diagrams, if you go like straight down the line, so if you like look at, this is the first section, this is the second section, oh sorry, this is the second section, this is the second section, they'll always add up to 1 within their section. So you just take the opposite. So for example, for this one, you've taken out a red marble, so 7 on 12 minus 1 equals 6 on 11. 6 on 11, so this is going to be 5 on 11 because we know it adds up to 1. Now, what about we had 5 on 12. We took out a blue, so we took out one of the total, but we did not take out a red one. So, okay, actually this, we took out a blue, right? We took out one on top, 4 on 11, and so this is going to be 4 on 11 if we go blue, blue. And then this is going to be 7 on 11 because we know it adds up to 1. Another way of thinking of it, if you want to do the red branch first, you take out a blue, it means you have 11 total, and then you still have your 7 because you never took out a red, so it's 7 on 11. Okay, so we've got our tree diagram. Now, if you want to go along a branch, you multiply the probabilities. So chance that it's red, red is 7 on 12 because it's picking a red and a red. So remember that word and means multiply. 7 on 12 times 6 on 11 is 42 on 32, which probably simplifies. Well, definitely simplifies because they both end in 2, but I can't be asked to simplify it. And then, so, oh wait, that was actually the answer to our first question. So I'll just chuck that up there. Didn't even realize, I was just showing an example. Probably that both of them are blue, same thing. We go along the branch, we multiply, it's a blue and a blue. 5 on 12 times 4 on 11 equals 20 on 132. So, actually I will simplify these. 7 on 22 and 5 on 33. And then 1 red and 1 blue. So it doesn't say in that order, right? It says 1 red and 1 blue. So it's either going to be we get a red and then we get a blue, or we get a blue and then we get a red. So 7 on 12 times 5 on 11, or 5 on 12 times 7 on 11. And you might realize if we're multiplying these fractions, like these two numbers multiply and these two numbers multiply, so it doesn't actually matter what order it's in. So we can actually just say 2. Well, actually, also this or here, we've said or means plus. So it's that plus that. And what I was just saying was like, if the top numbers are the same as each other, like it's a 7 and a 5, and the bottom numbers are the same, it's a 12 and an 11, you can actually just say 2 times this, and you don't even need to consider the second one. So that is going to be 35 on 66, or 53%. Okay, also they drew their tree diagram downwards in the answers. You can do that too. Makes no difference. Or, this is the other one I was going to show you. If you have like simple cases like this, where you only have, 2 branches that break into 2 more branches, you can actually just write down the letters. So, oh shoot, I shouldn't have erased that. So if you just look at these letters here instead, if we go like red, red, and then red, blue, blue, red, blue, blue, and then you just work it out like in your own working out. So you go, red is 7 on 12 times 6 on 11. Like, you don't need to draw the whole tree diagram. You can just work it out yourself. But that's more like, if you're well practiced, that's just a faster way of doing it. Achieves the same thing. Just another example, if you're doing like coin flips, you'd have head, 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 tails, tails, head, tails, tails. Like any sort of thing with 4 cases, you can pretty much just write down the letters instead of doing a tree diagram. Okay, Logan walks his dog every day. They walk by the river 5 days a week, and they walk around the block 2 days a week. When they walk by the river, they see other dogs 85% of the time. Okay, tree diagram again. They probably go downwards here again, but I like going sideways. It gives you room to write. So, by the river, around the block, we'll say R and B. And then dog, no dog, dog, no dog. So, river is 5 out of 7. Block is 2 out of 7. River dog is 85%. And no dog would be 15%. Block dog is 30%. Block no dog is 70%. So we just filled that out nicely. Determine the probability that Logan and his dog will see another dog. So the chances they see a dog is either this branch here or this branch here, right? So 5 over 7 times 0.85, or 2 over 7 times 0.3, because we're doing percentages, remember? And this or we've spoken about means plus. So 5 over 7 times 0.85 plus 2 over 7 times 0.30. And our answer is I feel like they've they've got the right answer, but they're working out it's wrong, so don't read theirs. They just treat it as 85 and as 30, which would not make any sense. But their final answer makes sense. 69.3%. Sorry, I'm just reading the answer key because I'm not bothered to use my calculator for all of these. But they wrote, for reference, 5 times 30, right, which would be 150 over 7, which is bigger than 1, which doesn't make sense for probability, right? So you have to make sure you enter it times 0.30 in your calculator. Okay, determine the probability that Logan and his dog... Oh wait, that's what we just did. Shoot, that's down here. My bad. And that's everything. Too easy.